Lesson 3, Texas tea and temperature. Using multiple representations to solve problems. Learning goals include use multiple representations to analyze and interpret problem situations, and use tables, graphs, and equations to represent and solve word problems by reasoning about quantities. In this video, we are going to be doing a think aloud, meaning I will be going through the activities, thinking and saying my thoughts out loud so that you have a better understanding of the types of concepts and strategies that you can use when working through this lesson. On our getting started, it's a matching game. 4 equations are given. Match each equation to a graph or a table and explain your reasoning. Then complete the table and graph for the unmatched equation. Our getting started is a introduction to the lesson. It is to help you review skills that you will need later in the lesson that you learned in prior grade levels or in prior lessons this year. So for example, if we look at number 1, y equals 6. There is no x, so it does not matter what number we plug in for x, we will always get 6, which is what table B shows us. All the values for y are 6. It does not matter what number we put in for x. So number 1, table B matches it. On number 3, I see y equals negative 6 plus, negative x plus 6. I see this plus 6, which tells me this is not a proportional relationship, which means my line does not go through the origin like on table C. What it tells me is that the line goes through 6 on the y-axis. That constant is your y-axis intercept, like graph A. Notice our line intersects the y-axis at 6. Which tells me that could be a match to 3. But let's also check our rate of change. Looking at this rate of change, our x or variable term, I see that it's negative. Because this is negative, my line has to slope downwards. It has a negative slope, meaning it goes down. And it goes down at a rate of 1. There is not a coefficient in front of the x because we don't write the 1. Multiplying by 1 does not change anything, so we don't have to write it. So when I'm looking at my graph, I'm checking to make sure that the rate of change is a negative 1. If I go down 1 over 1, down 1 over 1, down 1 over 1, I stay on this line. So this graph does match equation 3. At this point, we're going to move on to activity 3.1. Activity 3.1, starting with a verbal description to solve a problem. A tank that currently contains 2,500 gallons of oil is being emptied at a rate of 25 gallons per minute. The capacity of this tank is 3,000 gallons. So let's think about this. Before I start answering any of my questions, the tank, which is just a vessel, like a bucket, currently contains 2,500 gallons of oil. So that's where we're at right now. That's where we're starting. So that's going to be my starting. And it empties at a rate of 25 gallons per minute. 25 gallons per minute, that's my rate of change. Rate of change. And because the tank is emptying, that means it's going down, which tells me something's going to be negative or subtraction. And that something is this 25. The capacity of the tank is 3,000. The word capacity means the max or maximum. So the maximum amount that this tank can hold is 3,000. We're starting at 2,500 and it is emptying or decreasing 25 gallons per minute. Question number 1. How many gallons are currently in the tank? Well, that's what I'm starting with. So that's 2,500 gallons are in the tank. Whoops. How fast is the tank being emptied? Well, that's the rate of change when it's asking about how fast. That's going to be my rate of change. So it's emptying 25 gallons per minute. Number 3, what are the two quantities that are changing? So the two things that are going to be changing, thinking about the situation, well, the number of gallons in the tank is going to be changing. So the amount of oil in the tank, the gallons of oil. What else is going to be changing? Well, I see minutes, so that's a measurement of time. So time is going to be changing. So the gallons of oil and the time passing. Okay. Define variables for these quantities and identify which is the independent variable and which is the dependent variable. So gallons of oil and time. Let's just say that G will be our gallons of oil and T will be our time. Those are defining the variables. Identify the independent and dependent variable. Well, does the gallons depend on the time passing or does the time depend on the gallons? Well, time doesn't depend on anything. Time keeps going. So that means that time must be the independent variable. And the gallons is the dependent. What is the unit rate of change in this situation? The unit rate, unit means one, and I already know that the 25 gallons per minute is the rate of change per minute, per 1 minute. So that's a unit. So 25 gallons per 1 minute is my unit rate. 25 gallons per 1 minute. So that means for each minute that's passing, 25 gallons of oil is leaving the tank. Write an equation that relates the two quantities. Write an equation that relates the two quantities. Well, I'm starting at 2,500 gallons of oil. It's emptying, so subtracting 25 gallons per minute, and minute is a length of time, which I said was T. And that's going to equal the number of gallons in the tank. Well, which we said was G. I don't have to write out gallons. That's why we make a variable for it. So there's my equation. 2,500 minus 25 times T equals G. Let's keep going. How many gallons will be in the tank after a quarter of an hour? So I can use my equation that I just wrote. I'm going to write it over here so I don't have to keep going back and forth. 2,500 minus 25 times the time is going to equal the number of gallons. So how many gallons will be in the tank after a quarter of an hour? Well, that's hour, and my equation is using minutes. So I need to figure out first how many minutes a quarter of an hour is. An hour goes all the way around the clock. So if I divide the clock into quarters, a quarter would be this right here. That's 12. 1, 2, 3, and that would be 5, 10, 15 minutes. So if I take my equation, 2,500 minus 25, multiply that by 15 minutes, it'll give me the number of gallons that will be in the tank. That's what you need to do. Follow order of operation to see how many gallons are left in the tank after 15 minutes. B, 5.5 minutes. Well, that's already minutes, so that's 5.5. 2,500 minus 25 multiplied by 5.5 or 5.5 equals the number of gallons. An hour and a half. Well, I know that an hour is 60 minutes. Half of an hour is 30 minutes. So that's 60 plus 30, 90 minutes. So for C, we're using the equation and we're substituting 90 for our time. And again, following order of operation, multiply first and then subtract that product from our starting value.